I will talk about JChem Web Services. The agent contains 4 items. The first is about the overview of the products, which is technically JChem Web Services now are 2 products. I will start to talk about the old one, the JChem Web Services Classic, and I will show some SOAP examples in Python, and then I will talk about our brand new products which we developed in the approximately last half year, which is a brand new REST API, and I will show some JavaScript and Python examples, and then I will shortly talk about the future plans, and after that slide I will ready for answer questions. Okay, so the goal of these web service products is to provide a simple and ergonomic way to access all of the JChem functionality, especially from websites and so on. So it's make it easy to access these functionalities. The second aim with this product that provide access to JChem products from non-Java APIs. Like Python, or languages are like Python, Perl, and R. So you can use all of our computational and database products. And the last thing is that it may provide a nice API to integrate our product to even to Java products, where these products integrated through enterprise service bus or other service-oriented architecture. What I meant at the first point, that simple and ergonomic, that most of the function can be accessed much easier through the web service interface. You will see that, okay, certain examples which was took 15 minutes to explain at the plain Java API, then it's just basically some lines in the example Python code. Okay, so as I mentioned earlier, there is a classic web services, and this is the SOAP web service, which provide a bit heavy XML interface, which is standard and can be used nicely, but it's relatively heavy and robust thing. Somehow that the SOAP interfaces is still used in enterprise integration, but it's not as interesting or not as hyped anymore as earlier. And when we building kind of one web page, web applications where really everything is runs in JavaScript, the new REST interfaces which can produce typically JSON data structures or JSON representation for the data structures is kind of quite popular today, and these are more simple and lightweight implementation, and this is our new product. Okay, for the naming, till 6.0, so till the upcoming release, the JChem Web Service meant the classic one, and up from the 6.0 version, the JChem Web Services means the new one, and the old product renamed to Classic. We still maintain it, so if you need SOAP integration, you can use it surely. Okay, there was a quick comparison between the two products. So that the SOAP has currently more functionality, and we catch up with the REST interface, so you can see the version numbers. That this 6.0 version be released soon, I think within 1 month, and we have this kind of 3-4 months release period when the new version appears. So the 6.1 definitely contains all the features. Okay, let's see the SOAP examples. Let me talk first a bit about the structure of the the SOAP web services, so this classic web services. When you download the bundle, it's technically a Tomcat, which has an access to web service container, which contains our JChem Web Services. Everything is pre-installed, so technically you just have to start with the script files in the bin directory. There are some database drivers also included, so it's kind of ready to use product and bundle. You can find enclosed an Ajax and the GSP examples, and this slide shows these 3 main configuration files where you can fine tune the change port numbers and so on. Okay, so if you really want to see that, okay, what this product is capable of, you can open the access to. So after starting this product, you can open this site and you can see that we have the services which I already mentioned, like JChem Search Web Service, more Search, Standardizer, Markush, and so on. And you can see the visual interface definition of these. You can find the documentation enclosed with the product, or you can find it on the web page. So how this works? In SOAP view, typically you have this kind of SOAP envelope which package the request. This is a call for the chemical terms evaluation. So you send a target and you send the atom count to the service which I showed earlier here, and then you get a response, which is the number I just forgot it, which is the atom count of that specified structure, chemical structure. So our examples created in Python 3.x environment, and we use this suds Yurko library, which is a quite Pythonic one. And this is how the code actually looks. So you have to import the, you have to include the suds client library. You create a wrapper for a visual URL, and now you have kind of more converted wrapper object, and you can call the service called convert in this service. This says that if we have this my string, and which we send us as chemical structure, and we specify the parameter mole, then it returns a mole file in a string format, which you can save to a file. If you require a picture, that it's also possible. The only complication that technically the return data is base 64 encoded. So you have to use this binASCII package, which is a default or included package in Python, and then you can convert the base 64 encoded string and store it in an image file. If you want to connect to a database in Python with the old web services, you have to use 2 services actually. The first is a connection web service, which gives you a connection ID if you send to the server the database parameters and user parameter and so on. And with this database ID, you can search and retrieve data from the database. And when you finish all the operation, you can close this connection. Okay, so the next, so that was technically the old SOAP interface. And now I will talk about our brand new Python example, about our brand new product. First, this is currently just a developer preview, so you have a var file which you have to deploy in a servlet container. This servlet container, when starts, so that when the application starts, it's automatically create the initial configuration file, which contains 2 databases. I will just quickly show it. There is a product which is based on our web services called Plexus. This will also launch with the 6.0 thing, and this shabby database and the drug bank database is included automatically. So when you deploy this var, you can immediately see this. You have this database to play around. It also has a kind of interactive manual. So after installation, you have this kind of service available, and technically in this documentation you can have kind of live demo immediately. So you set up the base URL here, and this is the default one, and when you click to the URL, it actually will show the actual results which produced by the web service. You can see that, okay, what kind of database sources are available. This is my current configuration. And the sample is included only in the downloadable demo. And you can get some more information about the database configuration and so on. So let's start with some JavaScript example, and then will come the Python ones. These examples are kind of live also, so you just click here, it's sent to the server. You can see here the JSON response. You can see here a lot of kind of encoded text. Just increase a bit the size. And actually this is the molecule which is encoded in this kind of encryptic things here in this string. And you can also notice that in the JSON you just not only receive the picture, but it gets a link which you can insert to a web page if you want to do so. Here you can see the code which does the magic. You can see it's quite simple. So it's technically a plain AJAX call which receive the JSON message displayed above, and this technically visualize this image and load to the document object model of the web page. Let's see the second example. Okay, sorry, I wanted to mention in the URL that as you can see this REST call, that technically after the data tag you have to specify the name of the database and then the table name. And in all table you can reference to the molecules after the detail tag. You have this CD ID number, which is technically kind of row number in the data table, and then you say that, okay, we want to retrieve an image. Okay, in the next request we search in the database. The earlier request was a GET request. Now this will be a POST one, and it means that, okay, you have a payload specifying that what kind of search option you have. What you say here is that you have this page. Let's start with this paging option. What is included in the display? The result. And you have a search option, which means that you specify a query structure, and then you say that what's the search type, so it can be similar to search and so on. So if I execute this request, then we get the response, the usual image information, And we also get back the search option in the request. I mean the requested search option in the response. This is good for debugging because then you can see clearly that, okay, which parameter is interpreted or what is interpreted from your request by the server. So if you mistype something, you can see it here. For example, the server not recognized and so on. You can also notice that we displayed here the image which contains where the query structure here marked with blue, so it already contains the result of the. We can play around with the parameters. So if we already seen the first molecule, then we can specify that, okay, we just want to retrieve from the second molecule 3 of the results. Only the first one will be visualized. Actually, you can see it's a different molecule, but you can see here at the response that practically we have 3 molecules. Here we have the code which displayed this response. It's also a simple AJAX call. The only difference is that technically we get the first element of the returned array, because we return 3 of the items. Okay, so now if we finished with the search and we know that what is the result, we may be interested with some chemical properties or physical chemical properties of the result, and we can get details of a certain molecule. So here at the Shabby table, we would like to see the properties of the molecules with ID 2668. So I just send this post request. Here I said that, okay, I would like to include pKa calculation, and these are the parameters of the pKa. Oops. So this is the response. The basic advantage of this form of accessing calculations through the detailed view is that the advantage of this over the chemical terms, that practically it contains all the diagram data and all the details and so on. So it's much more, it's a structured information, and it's much more information that a symbol than the simple value which is returned by the chemical terms expressions. So this is the visualized result, as you can see, and we have a AJAX code here which is only slightly more complicated than the earlier one, which says that, okay, we want to visualize the molecules which was returned. The last JavaScript example is also a search example. Here's the trick, is that when I push the show, then it's automatically generating a table from the results. So this is the result. And you can see here the table. This is really just happened on the fly by this small code snippet. So you can see that practically it's a simple JavaScript code, and this is so easy to make a kind of building a table in your web page. You can play around with the parameters, like saying that, okay, the similarity threshold. You can see here in this parameter set that the search option now is a similarity search and not a substructure search as the earlier. And then just let's see a benzene. And let's see, the first 10 is boring molecules, so I just want to see the next 10. Let's say that it's show. It probably takes some time because it can contain some larger molecules as well. Come on. We are unlucky, and I just set it some parameter which is returned no result, so there is no such, not that much molecule which is similar to this query. Okay, that's a new query, and you can see that there are, you can see here the statistics that, okay, technically there are 7 molecules which were similar, which was 70% similar to the original molecule, which I defined there. Okay, so that was the JavaScript demo. And let's return to the slides. Now comes the Python examples. And this will start with a simple query, so how it looks like in Python. So you specify the URL here, which is similarly structured as the one in the JavaScript example. Here we start with a simple get query. You can also specify in get the paging parameters. So it starts at the offset 16, and we retrieve 20 molecules. And you can see it's a get request. And if we execute this command, then let's see what's returned. Yes, it was quite quick. You get a result which is immediately converted from JSON to a Python data structure, and we iterate through this Python data structure and display the structure ID, its own Shabby ID, and the Shabby name. So you can see that this is the 20 hit starting from offset 16. Let's see a bit complicated query. In this example, what I will show that it's sent. So, as if the parameters of the query is complex, you simply cannot store in the get message. So you cannot encode in the URL. That's why you have to post the search options, and there you can have this kind of JSON structure, which you have seen already. So it may be familiar to you from the previous JavaScript example. What I do here is try to somehow emulate a bit filtering for Lipinski rules, which says that as the molecular mass is already stored in the database, I just retrieve all the structures which has a higher mole weight, lower mole weight than, so this is LT is a less than operator than 500, and starting from offset 0 with limit 10, and I include log P and donor and acceptor hydrogen bond count as well. This is the actual code. When you send in Python with the request package, the request, what you have to include at the content type. So this is what you have to say to the server. The content type is application JSON, and then technically the post request is just that's long, so it's technically one line. And when you get the raw results, then you iterate through, and on this result set, we print the actual row, and then if we check certain parameters, so these are not the Lipinski rules of 5, because there is 5, but I just modified for achieve a bit higher speed in the example. So we filter out, and if these things are kind of fine, then we we do another post request to retrieve detailed data about the molecules in the database. In the database, you can identify the data with the CD ID, as I mentioned earlier, and what we show is the CD ID. No, sorry. We use the CD ID to retrieve, and what we will show is that the SMICE string of the molecule. Okay, so let's see how this works. Okay, so you can see the result of the query. The fail just means that, okay, the checking of the parameter, which was here, I think, I set it to less than equals than 2 and less than equals than 3 is not met, these conditions. And we can see that, okay, where is met, it's printed the SMICE string of the given molecule. The last part, so I think that you get it how easy to use this API. The last example I would like to show is just a simple molecule conversion. You can use something similar also to produce pictures. Here what I have is that I have a SMICE string, and I would like to retrieve the name of this strange molecule. So let's see, what is it? It's recognized automatically. We can do actually also in the other way around. So we're just specifying a common name and say that, okay, I would like to see the more file representation of that string, and what you can see is that here's the more file. So as you have seen these examples of using the new REST API, I have to mention that if you have to choose that, okay, you want to use the SOAP one or the REST one, and you don't have any specific requirements, so that, okay, you not prefer the SOAP because already all of your web service is running over a SOAP service. We recommend to use the new REST service, as currently we also build JavaScript application and web application on top of this API, which means that it's really tested in real conditions. It's quite ergonomic. Our current test environment is so we're supporting all the major database or most popular databases like Oracle, MySQL, Microsoft SQL Server, and Derby, and we tested in Jetty and Tomcat. If you want to deploy in a different environment, just let us know, and we will add also these additional servlet containers also to our testing environment to ensure that it works correctly there. Just returning a short for the Python example, I have showed you the search option already. Here's one more, the same search option structure, where you can see that the first part of this contains the similarity settings. Then we have this molecular mass less than 500, which I showed already, and they also have here this additional chemical terms field. So these new properties are did in form of chemical terms. So the last slide, and then you can ask some question if you want, is that the next step what we are going to add in the 6.1 version is provide some kind of built-in authentication mechanism. We would like to to expose also the server-side Java API for you. And we definitely improve ChemAxon 2 coverage. Our ultimate goal is to provide web service for all the Java APIs. And last but not least, as our existing SOAP API is relatively quite old, so it started to develop, let's say 5 years ago. We also going to update that and making a bit more ergonomic and provide migration from the old SOAP UI to the new one. Okay, so thank you for your attention for the presentation. Now you can ask your questions.